Good morning, everybody. Today we're going to look at the solutions to the 212, 213 quadrilateral proofs that we looked at on Thursday and Friday of last week. Now, please notice that this isn't the only way to do these, but my way is probably one good way. So if you can understand the ideas I'm presenting here, then hopefully that'll prepare you for other problems that are like this. So, by the way, one big goal that we're going to have on most of these problems is show that there are two congruent triangles. If we can say that there's two congruent triangles, then all of the matching parts that are left over are congruent by CPCTC. Corresponding parts of congruent triangles are congruent. So with that said, in problem number 1 on page 4, it is given that we have a parallelogram and we want to show that the opposite sides have to be congruent. Okay? So the first thing I know, because it's a parallelogram, is that the opposite sides are parallel. That's just the definition of a parallelogram. That doesn't make them equal yet, but it is good to know that they're parallel because in the next couple of steps, what I'm going to say is that there's some alternate interior angles. Now, alternate interior angles are always there, but they're only congruent if you have parallel lines. So both of those sets of angles are congruent because they're alternate interior angles and the lines are parallel. That's what we call the AIP theorem. After that, I can talk about the reflexive property in the center here. Segment AC is congruent to itself. It's in both triangles, so there's a congruent part that they both share. And that means that my two triangles, BAC and DCA, are congruent by ASA. Both of them have those three parts, an angle, a side, and then another angle in both triangles. And because the entire triangles are congruent, that means that the leftover sides that I actually cared about to begin with, AB is congruent to CD and AD is congruent to CB by CPCTC. Corresponding parts of congruent triangles are congruent. So now we can use that fact in the future. Okay, if we know something is a parallelogram to start with, we can say, oh, I know it's a parallelogram, so the opposite sides have to be congruent. Okay, that's going to come up later. So the reverse of that would be saying if we have the opposite sides congruent to show that it's a parallelogram. So I'm going to go through my steps there. Mark the given information first and foremost on my picture. So here's the opposite sides, which are congruent by the given information. Then after that, I would say that AC is congruent to AC, again, by the reflexive property. Done that quite a few times already. Now that is enough to say that the two triangles are congruent by side, 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 because all three sides are marked as being congruent. And then where I go is to show that these specific angles, these angles, I remember talking about these ones, are congruent by CPCTC. They're corresponding parts between the triangles, so they must be congruent. The reason I'm doing that is because if those angles are congruent, well, those are alternate interior angles with respect to lines AB and CD and lines AD and CB. So again, by the AIP theorem, if the alternate interior angles are congruent, then the lines must be parallel. And so to finish this off, since we established that both sets of lines are parallel, this has to be a parallelogram by definition of a parallelogram. In page 6, again, this time we get to start knowing that it's a parallelogram, and we want to show that angle B is congruent to angle D. The angles in opposite corners are the same. So given information, it's a parallelogram. Step 2 and step 3, hey, because we know it's a parallelogram, I know that the opposite sides have to be congruent. That is a major time saver for what I want to do here, okay? Because now that I know that the opposite sides are congruent, and this this side in the middle is congruent by the reflexive property, that's already my 3 congruent parts. So the 2 triangles are congruent by side, side, side. And then angle B is congruent to angle D because those are corresponding parts between these triangles. So they're congruent by CPCTC. Nice. On page 7, this time, again, we know it's a parallelogram, but this time we want to show that the diagonals are cutting each other in half. The diagonals bisect each other, okay? So here's what I know. I know first off that these two sides are congruent and they're also parallel because this shape is a parallelogram. That's what I have in my first 2 steps here. Now the reason I'm calling out those sides in particular is because it allows me to talk about the alternate interior angles here and the alternate interior angles here, which are pretty neat as far as I'm concerned. They're congruent by the AIP theorem. And then, because I've got two angles and one side congruent in each triangle, the two triangles, I'll highlight them in green just in case you're not sure which ones I'm looking at. This one right here and this one right here. These two triangles are congruent by angle side angle. And if those triangles are congruent, then their corresponding parts, i.e. this one and this one, those corresponding parts are congruent as well by CPCTC. Okay, on page 8, we have a little bit of given information. We want to show that this shape is a rhombus, which means that all of its sides are congruent. So let's mark what's given to start with. Here's HK congruent to HA. Here, also HK is congruent to AW. So I'm just using one line for each of those because they're all congruent to HK. And also it is known that KA bisects angle HAW. One thing that I can add that I just see on the picture is the reflexive property. Let's use a different color though. AK is congruent to AK by the reflexive property. And then, because it talks about KA bisecting the angle, I know that these two angles in the corner are congruent to each other because that angle A basically gets split right down the middle. So those two angles are the same. Now that is actually enough to say that my two triangles are congruent because I have side angle side in both of them. So triangle HAK is congruent to triangle WAK by side angle side. And if the two triangles are congruent, then all of their matching parts are congruent. For example, segment HK would be congruent to segment WK. And so that's what I talk about in my next step. Those two sides are congruent by CPCTC. And therefore, we've marked all four of the sides as being congruent, which means that HAWK is a rhombus for sure. Feels good. Lastly, I want to show that on this last page, given that HAWK is a square, which is a ton of information, I want to show that HKA is congruent to WAK. So to start with, given information, nailed it, HAWK is a square. After that, because it's a square, I know that all four of these sides are congruent by definition of a square. Then you're probably getting used to this one by now. I'm going to mark this side down the middle as congruent to itself by the reflexive property. AK is congruent to AK. And that is actually already enough to say that my two triangles are congruent by side, side, side. Please let us know if you have questions about any of this.